Hello, it is Thursday, March 25th, 2021, and today we are going to be continuing creating or remaking a little game in Unity. So I was asked, oh god, my hair. Wasn't this bad 5 minutes ago, I swear. Yeah, I tested the camera beforehand, and it's a little bit earlier than normal. I realized a second ago that the times on the actual pre-stream thing are off now because this is starting a little bit earlier than normal. Yeah, the stream is starting a bit earlier than normal. I've been wanting sort of an excuse to experiment with moving this stream around, and so I kind of found one, and I will take it. But yeah, I just want to see what will happen if I do that. I am looking for the actual game that we are trying to clone so that I can show it. I think it's here, yes. Yes, okay. So I have been asked to clone this and sort of go through it and explain what I'm doing, so I have been doing that. I chose to attempt to do it in 3D instead of 2D. That was a huge mistake. But anyway, the idea of the game is that you are this little mage, imps pop out of these little holes, and you shoot them with bullets. The cool thing about this game is that pressing different keys will cause the little crystals around me to change. So for instance, if I press like the X key, I get blue crystals, and that improves our fire speed, but it decreases the projectile size. I believe the Z key, or no, the X key, no wait, the C key, yeah. That increases our projectile damage, but decreases the fire rate. And so we can have any combination. So we get to have one red crystal and two green ones, and then we get this kind of color. And so it's much larger, it does a little bit more damage, but it's really, really slow. So this is the concept that we are working on. And we do have the movement and firing done. And we were working on the spawning yesterday, but we kind of got interrupted with running out of time and whatnot. So the plan is to work on this for 2 hours, and then I will probably take either 30 minutes or just only 10 minutes, and we will do another sort of 2-hour block of, just sort of programming in general, because I'm preparing to do the, the Dungeon Crawler Jam 2021, and this starts in 6 days, so we have a lot of preparation to do for that. I want to do something similar to what I did for the Scorespace Jam. But yeah, got a lot of work to do with all that, and let me group all of my windows. What on earth just happened there? Alright, yeah, let me group all of the windows again. Okay, cool. Alright, so this. We have these little spawner thingies, and we do have an enemy prefab. Whoops. We do have an enemy prefab. So, oh, where'd you go? Alright. This thing works. It will move after the player and try to hit them. I don't think it does any damage quite yet. We'll need to actually make that work at some point. But we do need to make the spawning work. So the way that we're doing that is that we have all these spawner components, or we have all these spawners. Each one has a spawner component. So these green things are. Then we have a controller. So let's go into the controller, because we were messing with that yesterday. So the way that the spawning works in in Grand Magus, as far as I can tell, is it seems to, what would you say? It seems to spawn in waves, and so what we're doing here is we are declaring a list of the spawner components, and then in Awake, we are setting that list to be equal to find objects of type. And this to list, in case you're not aware, that comes from system.link, because find objects of type returns an array of spawner component, and we actually want a list. Lists, as far as I understand, are a strict upgrade from arrays. There's no reason to use a list or an array when you can use a list. The list is resizable, the array is not. So what we could do is we could do this. This is just like an alternative way to do it. Because you can declare the list, and then you can put a collection inside of it, but instead of doing that, we're just going to do to-list, because to me, I like it more. It's just fewer characters, like just more concise. So yeah, that's what we're doing. So now that we have all of the spawners, what we need to do is we need to determine sort of the next wave size, and also when the next wave is going to be spawned. So I'm going to say protected int next wave size. And then we're going to say protected, actually we don't need to store the next wave size, we can just compute it when we spawn it. We can say protected float next wave time, I guess. So that's when the next wave will spawn. So what we're going to do is in private void update, we're going to say that if time.time, so what we want to do is if it's not time for the next wave to spawn, we want to just return. And say if time.time is less than the next wave time, then what we will do is we will return. So what this will do, if you're not aware, whenever you have a void method, if you just use a return statement, it'll just stop executing that method. So if time.time is less than the next wave time, only this part of the method will execute, this part will not. So what we need to do is after we know that if we reach this point, then it is time to spawn the next wave. So what we're going to do is we're going to make sure that we set the next wave time to be equal to time.time plus, let's say, random.range, I don't know, 0, or we'll say every 3 to 6 seconds we spawn a new wave. Yeah, between 3 and 6 seconds. And I think this is, oh right, max inclusive, right. So 3 up to almost 6. And so between here we need to do the actual spawn code. So the wave size, we want to say wave size, and we're going to say that that's equal to, I don't know, time.time divided by, well, so this is the number of minutes since the game started. Or we'll say time dot, I think it's game time? Or no, it's time dot, no, actually time dot time is right. So this is the minute. And so every minute what we want to do, I don't know, let's say that we want to every 15 seconds we want to add another one to the waves. Does that sound about right? Yeah, sure, 15 seconds. So we'll say that plus 2, so 2 will be like the default. And the issue that we're getting here is that this is a floating point number. So adding an integer to a floating point number, this all becomes a floating point number. And then we try to convert it to a, we try to store it in an int, and what it's telling us is it's saying this is the wrong kind of data. So like a floating point number is, integers are like 0, 1, 2, 3, and then floating point numbers are, 0.01, 0.00, 0.025 or something, or 1.23. And it's saying, hey, I can't really do anything with a number that has a decimal place, even if in this case it may not. So the way to deal with that is that there is a convert class in, I think it's called, is it called int.convert? No, it's just called convert. Oh god, I can't remember where it comes from. Is it float.convert or is it math.convert? No, there's a convert class, and I can't remember where it comes from. I think it's in system. I think it's just convert.toInt, right? Yeah, so there's this convert class. So if you need to convert between one data type and another, you can usually use this convert class. So let's say convert.toInt32. And so an integer. So hey Zaisha, how's it going? Yeah, math.floor to int would work as well. That's true. So yeah, there's also in Unity there's mathf.floor to int. So this works as well. I think this does the same thing. This is just the system version. The only reason that I would recommend the system version, I mean, I think you can also, if I'm not wrong, you can do this, I believe. Yeah, this is also valid. I believe this has the same effect, but like the sort of recommended way to do it is with the convert class. In this case, there's no, yeah, you can just cast. In this case, there's no difference, but the convert class is usually the recommended way to do it. Just because there are some, the only reason that I do it, the only reason that I'm recommending the convert class is because there are some things that don't convert correctly with a cast, and so it's better to just do it this way. Or at least, you know, and not for this specific thing, it doesn't matter, but for other conversions, it might matter. But yeah, you're right, you can just cast. You can also use Unity's floor to int, but in this case I'm going to use to int32. So yeah, every 15 seconds we're going to add 2 to the spawn. And this causes other issues. So I guess one thing, if you ever see this issue, oh yeah, just to tell you, Zaysha, I don't know if you're aware, but this is, the reason that I'm doing this is that someone asked me to clone a game who is like a complete beginner with Unity, so I'm trying to explain it and, like, you know, trying to go through all the simple little things as best I can. So I'm using int here, not var. But yeah, just to sort of explain all that. If you ever see this issue, it's telling you random is an ambiguous reference between blah 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 and blah blah blah. What it means is that there's a Unity engine.random and a system.random. There's 2 ways to fix that. One of them, you can say Unity engine dot random. So this tells it, hey, I want to use the random from Unity engine. But in our case, an easier way to fix it is you can say using random is equal to Unity engine dot random. But yeah, I just wanted to, like, I wanted to explain, like, I wanted to just make sure that you knew that that's why I'm going through, like, I'm going through stuff at a much, like, finer level of detail than I usually do. I just wanted to make sure it was, like, clear why. But yeah, like, I know it might be boring to the people who know a lot of, you know, who know how to do all this stuff, but yeah, that's kind of why. That's also why I'm doing the convert thing, is because just to let people know that it exists. But yeah, you're definitely correct with the math dot floor to int and also casting. Those all produce the same result, I think. But yeah, well, what this does is whenever you say using random equals whatever, is it just tells C# that, hey, anytime we use random, I just mean this one. So it just resolves ambiguous stuff. There's also other things you can do with this syntax, but I don't use it except to specify the random. So for now that we have the wave size, what we want to do is we want to say basically what we want to do is this is the number of times we want to spawn an enemy. We also need an enemy prefab, just really quickly. So I think game object enemy prefab. And so we can say serialized field. And so what this serialized field will do is it will make this enemy prefab visible in the inspector so that we can assign it. And so in order to do something some number of times, what we want to do is we want to use what's called a for loop. So we're going to say for, then we can say int, let's say enemy is equal to 0. We're going to say enemy, or we'll say, let's say for number is equal to 0. Number is less than the wave size. So basically what we're telling it is create a new integer until, basically do this until the number is greater than the wave size, or sorry, greater than or equal to the wave size. Let's say number plus plus. And so yeah, what we're telling it is we're telling it, hey, repeat this code until this is not true. So the first time through, it's going to be, let's say time is 0, so all of this will just evaluate to 0. So we'll just have a wave size of 2. First time through, we're going to have number being 0. Then the second time through, number will be equal to 1. And then the third time through, number will be equal to 2. So when number is equal to 2, it'll say, okay, is 2 less than 2, right? And it will not be true, so we'll only do this for the 1 and the 2, so we'll only do it twice. So what we need to do now is we need to pick a random spawner. That's one of the things, that's why I wanted to store all the spawners in a list, is so that we can pick a random one. And so what we'll say is so if we want to get a particular spawner in a list, what we can do is we can say spawners, and we can use these brackets. So this will give us the first spawner because lists are 0 indexed. So this we can say, you know, spawners of 0, and then we can say spawn. And then we have to give it a prefab, so we'll say the enemy prefab. So in this case, what would happen is we'd only be spawning the enemies at one of the spawners, so just to sort of show what happens with that and sort of prove that it works. We will do that really quick. So this is where the enemy prefab goes. Where is it? Assets, there it is, assets, enemy. So I believe spawner 0, I believe in the find objects of type, I think it's guaranteed to return them in the order that they appear in the scene. So if that's true, then this should be spawner 0. So the enemies should only spawn here, and they should spawn every 15 seconds. Another thing we need to do is they will spawn instantly. Actually, let me just show that. So they will spawn instantly. Yeah, so you can see we have 2 of them, and they are spawning on top of each other. That's a different issue. But you can see they're only spawning from that one spawner. So we kind of want to fix that. But in a couple seconds, we should see 3 of them spawn, which I think it just did. Yeah, that spawned 3, that spawned 3. So yeah, they're spawning on top of each other. That's a different issue that we can fix. But anyway, okay. So first things first, that was a little bit too fast. So I'm going to say between 5 and 10 seconds. Well, actually, let's say 4 to 8. That'll be fine. And so, first issue is that, one, they are spawning immediately. I don't want that. So what I want is next wave time. It starts at 0. We actually want to give the player maybe 10 seconds or, you know, a couple seconds to just get their bearings. So in the awake method, what we're going to do is we're going to say next wave time is equal to, I don't know, 3 seconds plus random.range, I don't know. Well, actually, no. We'll just say 3 seconds. Make it less complicated. That way, enemies don't start spawning immediately. And then the second thing we want to do is we know that the way to get a certain spawner from the list is to give it a number here. And we know how to generate a random number with random. So we will say the int spawner is equal to random.range, and we want to say between 0 and 5 because we have 4 spawners. And the way that random works, most random number generators, whenever they work, the way that they work is that they will give you the minimum value and it's inclusive. Then they'll give you the maximum value and it's exclusive. And the reasoning for that, or the reasoning as far as I am aware, is it has to do, it's like a very old carryover from like C and stuff. It's easier whenever you're doing things like modulus or whenever you're using like the list size or things like that. And whoops, I'm wrong. I don't want to do, right, this is why. This is one of the reasons. Because I was thinking 0 to 4, but no. There's 4 elements in the list, and you need 0 to, that's right, we want a number between 0 and 3, because our list has 4 elements, and so their indexes are going to be 0, 1, 2, 3. So the maximum index is 3, so the exclusive number would be 4. But yeah, the way that most randomizers work is that they will have the minimum be inclusive, so that means that 0 will be generated, but the max will be exclusive, so 4 will not be generated. And so, yeah. And so what we can do is we can take this int and we can just put it in here. And now they will spawn from a random spawner. So yeah, let's just check that out really quick. So as you can see, things don't spawn instantly. We have 3 seconds to wait, and you see now they spawned from those 2. But if we wait a couple seconds, they should spawn from different ones. There we go. Now you can see they're spawning from different places. yeah. And of course, if we restart, remember they spawn from the top two. If we restart, there's a strong chance that they'll spawn from two different ones. Yeah, they both spawned right there. So yeah, you can see that it gets randomized. And so what we can do to further condense this is we know that the size of spawners itself is going to be equal to 4, because we know that there are 4 spawners. Since we're generating from 0 to 4, what we can do is we can say to spawners.count. So count is the number of spawners that we have, so since there's 4, this code will do the equivalent thing. I think this is one of the reasons that it's generated, or that it runs as inclusive and exclusive, is so that you can just put the list size, like if you wanted to get a random index in a list, you can just say from 0, which is guaranteed to be the beginning, to count, which will never go over the end. And so this is a little bit better to do, just because rather than putting 4, maybe if we add extra spawners, this will still work. Yeah, we have that. So now we have another issue where the enemies are stacking on top of each other. And so the reason that that's happening is because the enemies can collide with each other, and that's something that we don't want. So I think there are, there's 2 box colliders here. Why are there 2 box colliders here? Okay, first off, let's remove that second one because I don't think it's doing anything useful. And so what we can do, in Unity, if you don't want 2 things to collide, there is in project settings, if you don't have this window, I think you can go to edit project settings, and since I have it open, it just sort of selects it, but you can't see any change. Like if I go to edit project settings, you see it'll select this. And if you don't have it, it'll open it. So there is, I believe, a physics tab. And down here, you see we have this crazy looking triangle. So what this does is these are the things that can collide with other things. And so these are all layers these are all the layers that we have. What we want to do is we want to create our own layer, and we want it to be called enemy, and we just want to make it so that enemies can't collide with each other. So the way that we can fix that, or the way that we can do that, I should say, is that we go to enemy, we open the prefab itself, we can go to this layer thing. So here it's on the layer, or on the default layer, and create a new layer. I'm not going to use layer 3, I'm going to use layer 6, and we'll call it enemy. And so now, I don't think I assigned it. No, okay, so creating it doesn't assign it. So we assign it here. And we get this choice, do you want to set the layer for all children? No, we don't. The only thing that needs to be on this layer is the box collider. Or sorry, the only thing that needs to be on the enemy layer is the box collider, because that's the only thing that does any collision. So this other stuff doesn't actually collide. So there's no reason for it to be on the enemy layer. I mean, it could be, like it doesn't change anything, but I'm not going to bother with it, just because having everything on every other layer just is really difficult. So what we do in this triangle is we say, okay, this is the enemy list, or sorry, in this case we'd have the enemy. No, wait, I'm trying to think how this would work. So you'd have, so the question is, does default collide with enemies? Yes, it does. Does the transparent collide with enemies? Yes, it does. In this case, we just say, does enemy collide with enemy? No, it doesn't. Now that way, enemies no longer collide with each other. So if we run this, they won't stack on top of each other, they'll just clip through each other. So if I have these two, for instance, I can make them sort of clip through each other. They don't stack. I'm trying to show it, but it's hard to show because they don't want to be cooperative. But yeah, as you can see, you have these that are clipping into each other, and they're not having issues, or are they? No. But as you can see, you have these two that are clipping through each other. They are floating, and I don't know why, but we'll have to deal with that at a different time. Yeah, you can see they're clipping into each other. It's because they don't collide with each other. And they're on the enemy layer. So that fixes that issue. And they still collide with our projectiles and everything. Okay, but I do have to figure out the floating issue. I think it's because they're moving, okay. So the issue is that they are moving not parallel to the ground. So that is an issue with how I have coded this. It probably means, yeah, okay. So their X rotation is not 0. We only want their Y rotation to change. I'm trying to think of why that's happening. Why is that happening? Is the player floating? No. No, okay. That's odd to me why they're doing that, but okay. We can fix that. Yeah, I'm actually confused as to why they're doing that. But whatever. No, wait, let me double check. So what are they looking at? I'm trying to look at the player.transform.position, which is the player controller's transform position, but I thought the player controller was here. It is. So it's at 0, 0, 0. So why... Yeah, they're being very strange. Well, there's that. They could be looking at that, but I don't think they are. I think they're supposed to be looking at this. Quite odd. I wonder why it would look at the center. Because our transformed opposition from the enemy should be at 0. So they should both be 0. And that's really weird. What we can do is we can do the same thing that we did for the player. So in the player component, was it here? No, it's in, where did I put the player controller? Here I put it, okay. We can do the same thing we did for the player. So with the player, we basically, where did we do it? We did it here. Yeah, we grab the look rotation, or we compute a look rotation, and then we get rid of the X and the Z. We can do the same thing here with the enemy component. So we have our look rotation, and now we can get rid of, we're setting the transform.rotation, we can actually get rid of this, and this should do basically the same thing, where we only look at the player along the y-axis. We only change the y-axis, I should say. So now we should not get the issue of them sort of floating like that. But I think we still are. Oh, no, okay. Yeah, they're aligned to the ground now, as you can see. And they're only changing on the y-axis. It's true here as well. So yeah, now we have the enemies obeying the laws of gravity as they should. You know, we're bound by the laws of gravity, they should be. Okay, yeah, I think we're doing perfectly fine. Alright. So now, the next thing we have to do is we have to sort of upgrade the enemies over time. And the way that we're going to do that is we are currently setting, or we're just spawning only the enemy prefab. We need to make this change with time as well. So this causes the wave size to change with time, and this will cause the enemy prefab itself to change with time. And of course we can change the wave size and stuff like that, but you know, we'll figure out the optimal way to do that at some point. So what we need to do is we need to make a couple new enemies. So I think we can duplicate this with Control D. So we can say enemy tier 2. So we'll just grab this. We'll make it a slightly larger enemy. So we'll say that the model is, I don't know, 0.5 and 0.5 and 0.5. And then it needs to be at 0.25. Actually, let's make this the tier 3 one. Yeah, I'll make this tier 3. Just so that it's the same size as the player. And what I want to do is I probably want to darken this somehow. Maybe lighten it, I don't know. Say red. Hey W, how's it going? Doing pretty good. I just decided to start the stream a bit early because I wanted to try moving it around to see if anything, see if it changed the viewership at all. Yeah, it's actually a pretty bright day out today. I expected it to be more cloudy. But yeah, just continuing work on the game. Ooh, the collision box is not the right size. Fix that. 0.5, 0.5, 0.25. So we have tier 3 here, and I want to, maybe we need to make the default one a bit lighter. let's say red dash 3. Let's make this a bit closer to orange. Oh, whoops. It's a bit too far. Okay, so let's go to prefabs. We will say this is the enemy, I don't know, tier 2. Right now the only differences are cosmetic, but they will be different in the future. So say this is tier 1, and you have the right name. Okay, cool. You don't. Oh wait, now you do. Okay. Confused for a second. I guess it doesn't rename them automatically, or it doesn't rename them immediately. You have to leave for a second, or you have to close the prefab. So yeah, these are 0.4. I actually want these to be a little bit smaller. So this should be at 0.15. Okay. And I want this one to be a little bit lighter. So go to materials, we have this be red 3. Okay. And now what we want to do is in, let's say, the prefabs here, instead of having a single prefab, we want to have a list of prefabs. And then what we want to do is we want to decide sort of the enemy power, I guess, or the enemy, yeah, sure, enemy power. It's going to be equal to, let's say it's 1 plus, or we'll say it's going to be every 30 seconds we want to upgrade the enemies. This probably won't be what we do in the, probably won't be what it ends up at the end, but, you know, whatever. We can deal with it later. Well, let's use this convert.toInt 32. So this will be the enemy power. And what we'll use this for is we'll use this for the index into the list. So every 30 seconds we'll upgrade the power of the enemies. So since enemy prefab is a list, we can, we actually need to put a cap on this where it is capped at 3, because otherwise at 1 minute and 30 seconds it'll go up to 4. So there are a couple ways we can do this. So we'll say the one that we're going to use is the unity mathf.max. And so we know that the maximum enemy power we can have is 3. So we'll say that this is the max of 3 or sorry, not max, we'll use min. That's the right one. And the reason that we want to use min is because this could become 4. And whenever this becomes 4, we actually just want to use 3. But otherwise, this will start out at 0. And nope, actually I'm still wrong. This needs to be 2 because this is an index. So since enemy prefab, this should really be prefabs. Yeah, so this will have 3 values to begin with. Yeah, so this will have 3 values to begin with. What we want to do is we want to say that the power is equal to the index in that prefab thing, or in that list of prefabs. So since it'll have 3 values, the max index is 2. So we'll have we'll have 0, 1, and 2. It's 3 values, but the maximum is 2. And so that's why I want to use minimum, because this might go up to 3. If it goes up to 3, if we try to access enemy prefabs at 3, we'll get an index out of bounds exception. So we want a 2 there. I know that's a little bit more complicated than I wanted it to sound, but you know, I think it'll make sense. So every 30 seconds we just upgrade the enemy power. That's what I'm trying to get at. So we have this new enemy prefabs thingy, and we can do the trick where we lock the inspector. We go into our prefabs, we can use shift to click here, and grab all of these and drag over here, and now we have 3. Okay, so if I did all of that right, which is potentially unlikely, every 30 seconds we should see different enemies. So let's see what happens. Okay, so we have our little level 1 dudes here, the orange ones. It has not quite been, okay, I guess it has been like, well, no, I guess it hasn't. We're still getting enemy tier 1s, okay. Okay, there we go. Now we have the enemy tier 2s. And now, eventually, eventually we should get some tier 3s at some point. In probably another 30 seconds we'll get tier 3s. Yeah, we're getting tier 2s. There we go, there's the tier 3s. So as you can see, the enemy power is increasing, the number of enemies is also increasing. Yeah, everything's going well. Alright. So now that we have that, what we need is we need the score to increase over time. So I think the game that we're trying to emulate had score, and it also had health. So to do that, we need to do some UI work. That's always fun. So in Unity, the UI, the way that you do UI is with a tool called a canvas, with a game object called canvas. Let's go over to UI. An easy way to create one is to just create some kind of UI object, and it will automatically create all the stuff we need. In this case, I'm going to create this text from Text Mesh Pro. Text is the type of game object, and well, it's the component. And Text Mesh Pro is it's a thing that Unity basically, I think, acquired, and it just hasn't been fully integrated into their platform yet. And so if we click on that, a couple things will happen. We'll get a canvas, we'll get this event system, and we'll get this text object. We'll also get this TMP importer, and I'm just going to click this Import Essentials. It still needs to be imported for whatever reason, and it opens Visual Studio for whatever reason when it does it. I don't fully understand, but the window will stay for, again, some unknown reason. And you can import the extras. I'm not going to do that. I'm just going to let it go. So this event system, well actually let me show the canvas. Canvas is this thing right here. It is absolutely massive. A good way to get to it is you just double click it, and then you can use these this little control here. You can either click the perspective button, or you can click the little square here. So if you click the cube, sorry, it's a cube, not a square. Click that, it'll go from 3-dimensional rendering to orthographic rendering. And so usually when you're working with 2D stuff, orthographic is the better way to go. So if I click this little thing here, it will just align the camera so that we can see what the UI looks like. So these are all the UI elements. This is a very hacky way to do UI that Unity uses. I'm not a huge fan of it, but it's the way that they do it, so it's fine. Basically, this is the screen, and this text is going to appear in the center of the screen. So if we go over to the game, you can see that new text appears over the actual game itself. So if we play that, we get new text over everything else. That's because it's on the UI level. And so we want to modify that, obviously. So the first thing we're going to do is we're going to change this from a constant pixel size. We want the UI to scale with the screen size. And a good reference resolution is 980 by 1020. Or wait, is it 920 by 1080? I always forget. Yeah, it's 920 by 1080. So that's just generally a good reference resolution. And it'll make this text a little bit smaller. But yeah. So what we want to do is we want this, we have two things. I think we need a score and health. Yeah, so the first thing we need is score. So I'm going to rename this to call it score. And then we will go, let's say this is bold, we will center it. And let's say that the wrapping can just be disabled. I don't want to deal with that. So I don't know, the text size can be 70. What we'll do is UI elements don't really have a floating position. They're kind of anchored to something. Like in this case, they're anchored to the center of the screen. That's what this means. So if I click it, what I want is I want the UI to be at the top, or the text to always be at the top. So we can anchor it to the top. In this case, it's not super relevant, but we can just sort of move it up. And as you can see, now it's always at minus 50 pixels from the top of the screen. At least the center of it is. We could change the center with these pivot and things, but we're not going to worry about that. I think a good starting point is 0, 0, 0. I think that's where their score starts, is it 0, 0, 0? Yeah, it displays 0, 0, 0 if nothing is being displayed. Okay. And how big is that? Yeah, that's probably big enough. The reason I use Text Mesh Pro, by the way, is so that we could easily add an outline. So I just click this outline box and I say maybe 0.2. I think that's fine. Maybe 0.3. That's probably fine. And I think we have this at bold. Yep. Okay. Let's say 0.25 actually. Yeah, it doesn't appear quite right on the screen. You do have to go into the game itself, or into the game window to actually see what it's going to look like. So yeah, that's visible and probably fine. In my personal opinion, the score counter in here is just way too large. But what can you do? You know, it was made in like 3 days or something, so. Yeah, so now that we have the score, we actually have to change it. What I'm going to do is I'm just going to throw the event system into the canvas so that they will kind of live together. So we're going to create some kind of HUD controller, I think. Or I guess we'll just call it a UI controller. So create a Unity script. We'll call it a UI controller. Our UI is going to be simple enough that it can be handled entirely by a single script. But in other games it may not be. So I'll get rid of all this. And what we need to do in order to reference this score component, or what we want to reference is we want to reference this Text Mesh Pro text UI component, and I don't know exactly how you're supposed to know what its name is. I don't know if Unity tells you somewhere. Let me see if I go to the help for it, what it will do. Like, I personally know what its name is, I just don't know if it tells you anywhere. Yeah, I don't know if it tells you anywhere, you'd probably have to look it up online. But I happen to know that it's called a TMP_text, and it comes from the Text Mesh Pro or TM Pro package. So you have to have this actually imported to reference it. So we're going to say protected, and it's called a TMP_text element, and that's going to be the score. And so we'll call it a serialized field. And so just to show it, if I don't have this imported, this text turns white and it'll tell me, hey, I don't know what that is. And so that's where we get TM Pro. So in the UI controller, what we want is we want a way to increase our score. So we're going to say, it'll have a public void, and we'll say set score. I don't know, we'll say increase score. Yeah, we'll have increased score, and then we'll say int amount. So this will be the amount where we're increasing the score. So we will have, for increasing the score, we need to know what the score previously was. So we're going to say protected int score. Say current score, I guess. Now we'll say score, and what we'll have is we'll call this score text. Yeah. Alright, so this is our previous score. We're going to say score is plus equal to amount. And then we will say score text dot text score text dot text. So this is the value that's showing to the user. We're going to say that that's equal to, and we'll say score. And then there's two ways that we could convert this to a string. So in this case, score is an integer, it's not a string, so C# is telling us with this, it's saying cannot implicitly convert from type int to string. To be honest, I don't know why it can't do that, but it says that it can't. So there's two ways to fix it. So this is an integer, this should be text. So you can either do, you can have, well actually there's more than two ways. But the way that we're going to do it is we're going to say, well, I'll just show you both ways. One of them is you can create an empty string, and then you can use the plus operator. And so this will turn an int into a string. The other way that you can do it, which is the, I think, preferred way, is you can say .toString. because this tells C# that you want to convert this into a string, and it'll do it in the most efficient possible way, or at least the most efficient way that it knows. But it's always better to communicate your intent as well as you can to the computer, as opposed to trying to use some trick. But to be fair, I've done this many times, like hundreds of thousands of times. So, but yeah, we're just showing sort of the more proper way to do it. So yeah, we increase the score, and we want to do this every time we kill an enemy. And so we'll probably do that in the enemy component. So what we could do is what we want to know, or for the enemy, when the enemy is destroyed, we want to add some score value to the player, or to the player's score. So in Unity we have a handy method called onDestroy. So private void onDestroy. And this is called whenever the game object is destroyed, as you might guess. So when the game object is destroyed, we're going to say find object of type. We'll say UI controller, because that's where we put our method. And then after we've found it, we'll say increase score. And in this case, we're just going to increase it by 10. Okay. And so this will just simply increase our score, and it'll change it on the UI. So before any of that works, what we need to do is we need to go into our canvas, and we need to add a UI controller. And then we need to set this reference here to the score text. That needs to be set to score. And so now, because enemies, when they die, they get destroyed, we will see our score increase. It won't do quite what we want, but it will work. So we hit new, and then we get 20. Now, the reason that we got 20 there instead of 10 is because there were 2 enemies stacked on top of each other. So in this case, there's only 1, so we only get 10. But it doesn't do exactly what we want, because remember in the original game, it actually shows... Ooh, interesting. So this occurs when you are destroying a game object in the editor. So basically we had 2 enemies on the field and they got destroyed. It will complain at you. It's not really an issue. It's just saying that because the editor itself calls onDestroy, it ended up destroying the UI component before it destroyed the enemies for some reason. And so by proxy, it's telling us, hey, there wasn't anything to actually use, but that doesn't matter. There's probably a way to fix it, but I personally don't know what it is. I think we can say, is it if application dot, oh god, dot in, oh my god, why? Is it like an is quit or something, like quitting, or I don't know how to, yeah, I don't know. There's probably a way to make it work a little bit better, but I don't know what it would be. But anyway, in the original here, what I believe what it does is I believe it will format the text, and we probably want to emulate that for no reason other than completeness, and it gives me a chance to show off some other stuff. So I believe if we kill one of these, yeah, we'll get a 10 there. Instead, we'll get a 0, 1, 2. So I believe the formatting, or I believe the way to format that is we go to increase score, and we can say score, and I believe what we can do is we can add a string here, and I think we can say 0, 0, 0. And I think this will work, if I remember right. So let me just check. I'll check how much I remember my, my formatting. And then I'll explain it. Yeah, okay. So what happens? You might be wondering what that means, or how that works. So if you're doing, say, this method of converting things to a string, you can't do any formatting, or not easily. But whenever you're using toString, if you pass a string into the format, what will happen is we're basically telling C# that we want to display at least 3 zeros. Basically, but if the score, like if the number would be, say, 10 or 20 or something, we want to display, 20 here, but we want to display the 0 ahead of it. So this is like a common formatting thing. You can look up number formats on the internet. The formatting strings is very long and they're very old and well thought out process that has very strange things. But yeah, that's basically what this does. Is it says, hey, show at least 3 zeros, one leading 0, and then whatever the value is. So that's why that works. The next thing we need to do is the player's health. So in Grand Magus, I believe what happens is you have 6 health, or maybe it's only 3. I think it's 6, so it's 1, 2, 3, 4, 5, 6. Yeah, you have 6 health because you can have a heart. So, what we need to do is we need to have a couple graphics. So to get graphics, we can go to free game icons net, or we can search for free game icons net. You'll get gameicons.net. And so I believe all of these are royalty free. I might be wrong, but I think most of them are at least. We can search for heart. And let's check out, oh yeah, there's heart, okay. And I just want like a very simple heart. Okay, we'll grab this. And we can set the size. I'm going to set it to 512. That is super overkill, but I'm going to do it anyway. And we'll just save that. And then let me go find that. I don't want that opening. All right, let's open it. And I will open it using a program called GIMP. So GIMP is a pretty cool program. It just lets you edit images. It's basically like the free version of Photoshop. So what we can do is we can first export this. Let me go export this into my game directory. So I always export things to assets, images. And I know it's not on screen, but I'm just going to keep it off screen because my file system is a mess. So I'm going to call it heart full. And then I'm going to select here, and that's perfect. And we're just going to cut it in half. And we'll say file export as, and then we're going to export it as heart half. Half. Okay. It's okay, yeah, it's showing, right. Right, so now that we have those two things, wait a minute, why are you not, oh, it's showing up over there, okay. So now in images we have heart full and heart, did I not export it? I don't think I exported it. Let me open this again. That's very weird. That's super weird. Sure. I think Unity is just broken. So what we'll do is we'll turn this to, oh no, actually I know why it's doing that. It's because it's not parsing the alpha channel. Okay, so we'll say sprite, this is going to be 512. Then we'll apply, now it works. Okay, so what's happening is that image has an alpha channel and Unity was not displaying that because it was in RGBA mode. In default, it's only in RGB mode, so if we apply it, you can see that the pixels, this is only RGB. It says RGBA, but it's not. Yeah, it's not RGBA, but it's showing as RGB. So there's no, basically there's no transparency in this image. So there's actually the, you can see that it's a white heart surrounded by black. The pixels are actually here, there's just transparency here. And so that's why converting it to a sprite will cause it, whoops, cancel that. That's why converting it to a sprite will cause it to not show. So there's a couple things that we need to do. In our canvas, we need to create a game object. We'll probably need to create a UI sprite, right? No, UI panel. And that, we're going to set it to be centered. That way we can set the size and the width directly. So we'll say, I don't know, 64 by 64. Let's probably a decent size. Actually, we'll keep it in the center. And I'll double click. So this is going to be the heart background. And what we'll do is we'll set this to, I could swear we set those correctly. Whoops, I don't want to do any of this. I want to do that, and I want to do that. And I want you to not be a thing. Okay, so let's set this to heart full. So this is the background for our heart. And this will have, I guess, some kind of grayish color. Like kind of, yeah, sort of a gray color. And then what we'll do is we will duplicate it. And then we'll set this to a half heart. So there's a couple ways we could do this. Actually, no, let's not do it that way. Let's not set it to a half heart. Let's set it to a full heart. And then we'll turn it some kind of reddish color. And let's set this, instead of being centered, we're going to set it to be basically filling its parent, and we're going to set that to be the parent. So this is the heart, whoops, this is the heart itself. And then so now if I set, these are like the insets, so if I say like 5, 5, and 5, and 5, that's not going to work. It'll have to be like 3, 3, 3, and 3. It's not perfect, but you know, we could make it a little bit better, but it'll work for now. So actually, sure, let's do that. Yeah, basically what's happening is the outline doesn't quite work because of the way that I've done this, but it's fine. We can fix it later. This is just to show the concept. Anyway, what we're going to do is whenever the player takes damage, we're just going to replace the sprite here with half a heart. That way we can have this display all the states of the heart, so it can either be full heart, half heart, or no heart. Whoops. So what this does whenever we have the stretch and stretch, it'll basically make sure that there's a 2-pixel gap between the edge of this one, or the edge of this sprite, and the edge of this sprite, because this one's the parent. And so yeah, these are going to be our little hearts. Let's make these actually a little bit bigger. 128 by 128? It's way too large. Alright. Fine, we'll stop using cool values. We'll just use 80 and 80, right? That's probably fine. That's probably fine. And let's set the inset to be 4 instead. Yeah, that'll work. Okay. So this will be our, actually we'll call this just a heart. And then we'll just say heart fill. And so this is one of the hearts. So there's a couple things we can do here to make sure that these are evenly spaced. Yeah, I want to make sure that they're evenly spaced. So what I'll do is I will add a parent, and I will set its size to 0, 0. Then I will add a vertical layout component. And so what the vertical layout group will do is it will basically make sure that, or sorry, not vertical, what am I doing? Horizontal. A horizontal layout group. And so what this will do is this will make sure that if I have multiple hearts, that they are spaced evenly. So the horizontal layout group, what it does is it goes to each child, so each heart here, and it will try to ensure that they have equal spacing, that they're on the same y value, etc., etc. So if we say 10, we can sort of space them out a little bit. And so for this, I will just anchor this to the top, and I'll put it at 0, 0. And let's say, I don't know, 50, no, 30, and 30, or minus 30. Yeah, there we go. So the hearts are at the top, they're evenly spaced, etc., etc. I could evenly space them myself, but I don't want to do that. I am too lazy and cannot be bothered. Let the computer do it. I believe I can also take them out of here now that they're spaced, but there's no real reason to do that. So we'll say this is the hearts. So now, what we need to do is we need to make sure that each one of these hearts, whenever we take damage, displays the correct number. Or sorry, not the correct number, but it needs to display correctly. So we're going to have a heart component for that. Create a new C# script. Call it a heart component. Whoa, I don't know where that went. Create a new C# script, yeah. Heart component. Okay. So what this heart component is going to do is it's just going to make sure that each heart is displaying the correct value. So the heart has 3 values, right? It has 0, 1, and 2, because 0 means there's no heart there, 1 means there's half a heart, and 2 means there's a full heart. So what we're going to say is we're going to say public void set value. We're going to give this an int, and it's going to be a value. I mean, I guess there's a couple things there's a couple ways we could do it, but I'm not going to really worry too much about it. Well, no, actually. So now there's 3 things that we need to reference. The first one is the sprite for. We need to know what sprite to display when there's a 2 here. We also need to know what sprite to display when there's a 1, and we need to know what sprite to display when there's a 0. Or in the case of that, there's going to be no sprite displayed. So we'll have a protected, and it'll be a sprite. And this will be the full heart. Say full heart. And then we'll have a protected sprite. This will be half heart. And then for no heart, we're actually not going to have a sprite. What it's going to be, we could have a sprite for that, but we're not going to. We're actually going to just set this image to be hidden. It's actually going to be the fill image. Let me select the third one. So if we had taken 2 damage, all we're going to do is we're going to deactivate this image, so that way it shows as an empty heart. And so the way that we're going to do that is we need to reference the image itself. We need to say protected image. An image comes from Unity engine.ui. That's where we get image from. And so this is going to be heart fill. And so all of these need to be a serialized field. And so we needed this heart fill anyway, because when we change from full to half heart, we need heart fill. We need to know what it is. So the first thing we're going to do is we're going to determine we're going to say if value is equal to 0, right? That means there's no heart. So we're going to say heartfill.enabled equals false. We're going to say if value is equal to 1, then we'll say heartfill.sprite is equal to half heart. And we're going to say if value is equal to 2, then the heart fill is equal to, or .sprite is equal to a full heart. And of course this is not going to work, although it will look like it works for a little bit. So the issue is going to be that whenever we, well actually no, I think this might actually work. Never mind, I think I'm wrong. No, I think this will work because there's no healing in the game. So yeah, I think this technically is enough to make it work. Let's try it. So now that we have this heart component, right, what we do is when the player takes damage, let me try to think about this. So in the UI controller, we're going to have, I think, a list of heart components. So we're going to have a protected. Actually, I'm trying to think of how to do this in an easy way. So okay, the first thing we need to do is we need to assign the values on the heart components. So what I'm going to do is I'm going to delete these 2. And then we're going to add a heart component here. And so now we have the full heart sprite, the half heart sprite, and the heart fill. So the heart fill is going to be the image. The full heart sprite is here, and the half heart sprite is here. And so now we can duplicate this. And so we'll call this heart. Yep. So now, what we want to happen is when the player takes damage, we want to go through the hearts and make sure they have the correct value set. So we need to store those hearts in a list, so we need protected list of heart component. And for lists, we need using system.collections.generic. As I said, it's good to memorize that because you're going to need it a lot. Ideally, it would be best to set up Visual Studio to do this automatically for me, but you know, one step at a time. So we need a list of heart components. This is going to be hearts. And so whenever we take damage, so have a public void take damage, let's say int amount. And we also need to store our health, right? Because we need to say health minus equal to amount. So this is our health. So we say health minus equal to amount. So that's now our health has the correct value. And then in hearts, what we want to do is we want to say, or for setting the hearts correctly, what we can say is if health. So if our health is greater than, well, actually, I'm trying to think of the value. So what we want to do is if the health is, let's do this the long way, then we'll do it the shorter way. So if our health is less than or equal to, or is less than 2, then we want to say hearts, of 0 dot set value to be equal to the health, right? So that's if our health is less than or equal to 2, right? So if we have 2 hearts. I'm just going to use these to represent hearts. So if we have 6 health, this is 6, this would be 6 health. We want to display that. If we have 1 health, we want to display this. If we have 2 health, we want to display that. Right, so these are considered like both halves of the heart. So that's why we say if the health is less than or equal to, or is less than 2, then the only cases we have are 0 hearts, which would be that, 1 heart, and we already have the heart displaying. So if it's less than 2, we have these 2 cases, right? So now we just set the value equal to whatever our health is. Okay, that seems fine. Actually, let me do this the other way. Let me say that, okay, actually, let me just do the whole thing. All right. So at 6 health, we'll have 1, 2, 3, and let's duplicate this many times. So this is 5, 4, 3, 2, 1. Duplicate this at 0. So at 0 we have that, at 1 we have that, at 2 we have that, 3 we have that, 4 we have that, 5 we have that, and 6, right? Okay. So if the health is less than 2, hearts at 0, which is the first heart from left to right, is equal to, we just set the value, right? But if our health is equal to, or is less than, let's say, 4, then what we want to do, or sorry, yeah, if it's less than 4, then we want to say hearts of 0. So if health less than 4, then we would say hearts at 1, which is the second heart here, right? That's going to say, we're going to say set value equal to health. Then I think it's health modulus 2, right? I think that's right. And, well, no. I mean, I know that I could do this in a very complicated way, but I'm trying to find an easy way to explain it. Okay. Let me not worry about it. Let me do it the more complex way. So we'll say hearts at 0. Say set value is equal to health. We'll say if the health is greater than 2, or health greater than 1. Yeah. So we're using what's called a ternary expression here. So a ternary expression is like a very compact if statement. So we'll say is if the health is greater than 1, then what we just say is we use 2. Otherwise we use health, right? So what this does, this says if health greater than, or if, yeah. Let me just see if this will work, because I think it will. Let's say hearts of that is equal to health greater than 3 at 2, otherwise health minus 2, or health minus 2, I think. Because if the health is, let's say, 2, or yeah, let's say the health is 2, set the value equal to health minus 2, but that would be negative. It's not doing what I want. There is a way to do this, but I cannot think of what it is for the life of me. And it's really just my brain not having, my brain just not being able to think, not being able to use like super complicated stuff. Like there's a couple ways. Okay, tell you what, we'll just do it the dumb way. We'll just do it like the super dumb way. All right. So rather than trying to change the graphic, what I'm going to do is I'm just going to set the heart full to be half, and then we will just duplicate it, and yeah, just duplicate it, and then we can invert it by setting the scale equal to -1. That way it looks like a full heart. There we go. So now for each heart we have 2 heart fill graphics, or we have 2 heart fill images. And so for the heart component, we'll just call images. Hey, One Shot, how's it going? How is your Among Us clone going? So we'll just call this heart left. Let's call this heart left and heart right. How about that? Because my brain is not going to think this morning. All right, call this heart left. Then we'll say, God damn it, I'm trying to grab this. All right. Because I know you were talking about a clone for Among Us, and curious if you figured out the canvas stuff that you were asking about. So I'm doing good in Las Vegas, taking a break off school. Oh well, that's one heck of a way to take a break. Oh no, you didn't. Oh, you didn't. Did you try it? Because I mean, if you still need help with it, I can help you. But I mean, I guess if you're in Las Vegas, sure, you're probably not thinking about like game development stuff. Probably many other things to think about in Las Vegas. So for set value, what we're going to do, we're going to say if, well, actually, no, we're not even going to worry about this. We're not even going to worry about the heart component stuff. We don't even need it. Just going to get rid of it. In the UI controller, what we're going to do is we're going to store a list of images. Images. We're going to say using Unity engine.ui. Then what we'll do is we'll say for int heart, or for int health equals 0, health less than, we'll say hearts. Say for heart is equal to 0, heart less than hearts dot count. Let's talk about it later because I can't do anything for it right now. I left my laptop at home. Yeah, that's fair. Yeah, I figured if you're in Las Vegas, you probably wouldn't be doing anything with game development. There's too much other interesting stuff to do in Las Vegas. I've never been to Vegas, but I know people that have, and they've shown me pictures and it's really cool. I really want to go at some point, but I think that going right now might not be the best time to go. But I don't know. I live in Texas, so maybe it's not so bad. Yeah, I can't. How much stuff in Las Vegas is actually open right now? What we're gonna say is hearts of heart is equal to, or dot enabled is equal to health greater than or equal to heart. Yeah, sure. And what do you mean? In what game you tried to remake? So someone who was watching the stream asked me to, or I was playing some games for the Squarespace Jam, and someone saw this game, and they had asked me to remake it and explain sort of what I was doing as I was doing it. And so the concept of the game is pretty cool. You have these three little crystal thingies that float around you, and what they do is they determine how your shots work. So like right now you can see we have these really great, great big shots. But if we say press X 3 times, the crystals turn blue. And so what happens is our shots become really quick, but they're also really tiny and really weak. So yeah, have the little, have these little shots. But what we can do is if we hit like say C, we get really powerful shots now, but they're really slow. And so now we can have some kind of, combination. So if we want massive shots, but we want them to be more powerful, we can do that. And so that's kind of what we're doing in Unity, right? Is we're trying to remake that. So, and this hotel Wi-Fi is being stupid. Yeah, hotel Wi-Fi is, I don't know, it's always terrible. I don't know how they can manage to make it so bad. But yeah, right now we have something similar. I'm remaking it in 3D just because it's slightly easier to explain in 3D. There's a missing script, that's fine. Missing script is from the heart component previously. Get rid of all of this. But yeah, I'm just trying to go through and explain how I would remake that. Yeah, I was explaining to someone how I'd remake that in a, in sort of a slow and simple kind of way. So we have the 3 crystals here. If I press the C key, we get really powerful shots. If I press, the X key, they turn blue, and they're really quick now. If I press the Z key, they change size. These are a little bit bigger, but they're also a little bit slower. Now they get a little bit bigger and a little bit slower, and finally really big, but also really slow. So yeah, can do a similar thing. And we also get score, and so now we're working on the health system. And so that's what I was doing. But yeah, whenever the enemy is coming into contact with us, we need to take damage. And we need to lower our health. So to demonstrate that the take damage stuff works, what we're going to do is we're going to say heart enabled is equal to health is greater than heart, strictly speaking. So if health is 6, that will work. Okay. So in the UI controller, what I'm going to do is in private void awake, just to show that the health stuff is working, we're going to say take damage. Let's say we take, I don't know, 3 damage. And so health actually needs to start at 6. So if we take 3 damage, we'll lose the first heart and half of the second one, because that's half of our health. And so if we see that, that means it's working. Something is broken. Right, because we're not setting this to an object. Okay. So in hearts here, we have not set, not in hearts. In here, we haven't set this equal to an object. Right, because we haven't gone through and serialized it out. Okay. Okay, so yeah, we have our hearts here, and we want these to be in reverse order, so we can't really grab them from the UI like we did before. We actually need, I think this is the correct one. Yeah, that's the correct one. Okay. Yeah. So what we're going to do is we're going to lock the inspector here. We're going to put this one here, that one there. Oh wait, no, I'm wrong. Yeah, I'm wrong again. So actually no, because of the way that this worked, we can just grab these from the inspector. Let's put them here. That didn't go where I wanted them to go, of course. There we go. Now we should see ourselves take damage because of how that ended up working. So yeah, as you can see, we take 3 damage, so our hearts are missing halfway. Okay. So the way that I did that, so we know that we have 6 hearts, So what I did was I said for each number from 0 to whatever our hard.count is, we will just say that the image is enabled if, so like that half heart is enabled if our health is greater than whatever the heart number is. So if it's half heart number 3, right? So we have 3 health, it goes, 0, 0, it'll go 0, 1, and then 2, and then for the third one, or for the fourth heart here, fourth half, it'll say this is equal to 3, 3 is less than, or sorry, this will be heart like half number 4, but it will be the it'll be index 4, but no, it'll be index 3, or I can't think of what I'm trying to explain. So this will be the first half heart, but it'll be 0, this will be 1, and then this will be 2. And so what we'll say is if 2 is less, or 3 is less than 2, which it's not, so we will, it'll stop there. That's basically what it does. It's hard to explain, but yeah. And so we can get rid of this. That was just to sort of demonstrate what was happening. So now when the player collides with an enemy, or when an enemy collides with the player, one or the other, we need to have the player take damage. So I guess from the player's perspective, we'll do this. Whenever two things collide in Unity, we get a method, or a method call is called, the method is called onCollisionEnter. You are like my game dev teacher. He tells me what code it is and what it does and how it works. Okay, I hope that's good. Like the whole, I don't know if I've ever explained like why I'm sort of trying to start, or why I'm trying to do this. So the issue that I ran into after I learned how to develop games is that I could never find anyone who was just like working, like just doing development. Like you can, so like on YouTube, you can look at a lot of tutorials, but the problem with tutorials is they're sort of like this pre-packaged solution. Like they're very you know, well thought out and very well scripted. Okay, that's good. Yeah. So the issue that I had with tutorials is they're super well scripted and super well thought out, and you can't just, you know, my question was always, you know, how do other programmers like solve problems? And I could never find, you know, like video recordings of that. And so that's kind of what I want to do with this stream, is that I just want to say, okay, this is how I'm thinking through the problem, you know, this is how I see the problem, this is how I'm solving it. And so that's kind of what I want to do. And so yeah, like a major weakness that I've always had, you know, in my life is that I can understand code like very well, but it's very hard for me to explain it to other people. So that's kind of what I've been, that's another like sort of skill that I've been trying to work on with this. So I hope that it's helpful, and if it is, I'm glad, because that means that I'm sort of improving at that skill. But yeah, like I can think very easily in code. It's just explaining it to other people is the issue that I have. But yeah, what we want, so let me try to explain what we want and make it maybe a little bit better. So, you know, we have our game here. Whenever an enemy runs into us, we want to, you know, like that, we want to be taking damage there. So in Unity, what we get, whenever two things bump into each other, we get a method called, onCollisionEnter gets called. So we can say private void, I think it's onCollisionEnter, yeah. Unity knows what it's called. And so yeah, this is called whenever one thing bumps into another. So what we want to say is if collision dot collider, I think it's other. Yeah, dot other. No, is it collider? It's collider. So, but my game teacher didn't really make games, he just made a little click AI where the AI runs to where you click. Ah, okay. Yeah, the other thing too is that I don't want to show just you know, simple little mechanics. I also want to show, you know, the start to finish kind of process for making a game. Because while it's, you know, while like each individual mechanic, it's easy to explain how to make, putting them together, you run into a lot of issues. Yeah. But I mean, for like game dev classes, like one of the problems that they have is that the teacher is, you know, the professor or teacher or whatever you would call them, they have to explain the same thing kind of at a very slow pace because they have to explain it to, you know, 20 or 30 people. Whereas with Twitch, right, there's fewer people to explain it to, plus there's other people to help, and plus, you know, I can take as long as I want, and other people, you know, people who are asking questions in the chat can always, you know, phrase their question however they wish. So you get that sort of advantage too. But yeah, the other thing I'd like to show off is, you know, how mechanics fit together and how they kind of push up against each other when you put them in the same game, and how you sort of resolve that conflict. So what we need to do is whenever we bump into something, we might not necessarily bump into an enemy. We might bump into like a wall or something, or a projectile. And so what we want to say is we want to say if collision dot collider, I think this is the other collider, the collider we hit, yeah. And so we're going to say, well, actually what we want to do is we want to get an enemy component. So we want to say enemy component. We're going to call this the enemy is equal to collider dot get component. Not get components, just get component. I want to get a type of enemy component. And why did that not work? Oh, this is get component. I get components. There we go. And so in C#, one of the things that Unity did that was really nice is they made units or components implicitly convertible to null. Basically, what that means is in get component, if the other game object isn't an enemy, it won't have an enemy component. So this will return null. So enemy will be equal to null. So what we can do is we can say if enemy equal to null, but actually because of the way mono behaviors and things work, you can just say if not enemy, and this will be true when enemy is null. So if there isn't an enemy, we just want to return, because we don't want to do anything else, right? So if there's no enemy and we bump into something, we don't care. We bumped into a wall, we bumped into a projectile, it just doesn't matter. So we want to just return and stop doing anything. But otherwise, we know that now, if we get to here, there is an enemy there. So what we're going to say is we're going to say, we're going to find an object of type, the UI controller. So we're going to find the UI controller, and we're going to say, hey, take damage, and we're going to take, 1 damage. So that way, every time we end up touching an enemy, we'll take 1 damage. So if I did that correctly, which may or is more or less likely, if we hit U, see, we took 2 damage. That's because there's 2 enemies there. But if only 1 touches us, we only take 1 damage. So yeah, there's no effect that's being played quite yet, but we can always fix that later. And so right now, I don't know. Okay, that's interesting. Oh yeah, we're having some issues because of various things. I think we can't, yeah, we're being pushed around, which we don't want. But yeah, what's happening basically is we are getting sort of crunched between like 2 enemies. But note that whenever we like collide with the wall, we don't get any issues, like we don't take any damage. And when we collide with our own projectiles, we don't take any damage. That's because we're checking for the enemy. So yeah, as you can see, we're being pushed up. If I can find it. I'm gonna get out of this. I'm gonna go to the player. So as you can see, we're being like physically pushed up here. We really don't want that to happen. We also don't want enemies to get physically like pushed into the ground. That's not helpful. So I gotta think about how to deal with that. The enemies could be triggers. That's how that could work. That's probably how that should work, actually. The enemies themselves should just be triggers. Let's try that. Wherever I might have put the enemy prefab? Sure, let's just set you to be a trigger. Can't you constrain the rigid body? Oh, actually, that's a better idea. That's a better idea. W has a better idea. Yes, actually, yes. We can show off a different feature of Unity. That's a good idea. I was not going to do that. I was going to do it the hacky way. But yeah, so rigid bodies, as W just reminded me, they have this constraint. So right now we're getting pushed up. If we don't want ourselves to be pushed up, we can just constrain the y-axis here. And what that'll do is that just tells it, hey, Unity, when you're doing physics collisions, don't move anything on the y-axis, only move it on the x and the z. And just as a reminder, the y-axis is the vertical axis here. It's kind of weird. Most people expect it to be x and y, but no, it's x and y. X and z is the actual plane that we move on. So we can do the same thing for the enemies as well. We can just constrain their y value, and that will work because all the pushing is happening with physics. So yeah, I like that. I think that will work. Yes, as you can see, we're getting pushed around, but we're not actually moving. Our y value is never changing. If we grab this, well, it is changing, but to a non-appreciable degree because it can't. But yeah, as you can see, they can push against us all they want, and we will never move, and they will never move. Okay, that's awesome. Thank you. That's much easier than my solution was going to be, because if we made the enemies into triggers, actually, now that I think about it, they'd be able to move through the walls, and that would not be good. So, yeah, simple solutions. It's always good to have a pair programmer. Yeah. So there's a couple other things we can do. So one of the things we can do is whenever we take damage, we probably want to be pushed back a little bit so that we don't get, we want two things. We probably want to be pushed back a little bit, and we probably don't want to be able to take damage for a little while. So what we'll do for the pushback part, that's actually very easy. I think we have a rigid body reference here. Yeah, we do. Okay. So when we reference the rigid body, or so what we do is whenever we take a hit, we want to say rigid body dot add force. We can add a force, and what that will do is, well, actually, I don't think that'll work. I think that won't work because we're controlling the velocity directly. Yeah, we're controlling the velocity directly. No, it's fine. I know how to deal with it. So what we'll do is we'll add a force, and the cool thing is that we can get the collision. I believe the normal, or I think it contacts of, let's say, 0.normal. So what this is, whenever you collide, Unity will compute like the direction of the collision. And so contacts of 0.normal should be, or actually no, that's not what that is. Never mind. That's different. No, we need to compute the direction of the collision. So what that's going to be is if two things bump each other, it's just going to be the direction it's just going to be the inverse of the direction from one thing to another. So we'll say vector3, the direction is going to be equal to the collision, not collider, dot game object. So this is the other game object, and we're going to say dot transform dot position. So this is where we want to go, or sorry, this is where we are, and we want to say that where we want to go is the our current transform dot position. And so that is like an inverse. So what we'll do is we'll debug.log. We'll just log the, or not log, but we will draw a line, or no, we'll draw an array. And that will be from the transform.position, and the direction will be the direction of the ray. Actually, no. I want to draw it from here, from this position, in the direction. And so this will just show us the direction that we're computing here. This will tell us that this is what we want. The ideal case is that this will, well, actually no. The direction, no, it should be from our transform. From our transform is where we want to draw it. Yeah. So if we've done this math right, what we will see is we'll see a line that points away from our, like the center of our game object, because that's the direction that we want to be pushed back. And the reason that we want to be pushed back is so that we don't like immediately take damage again. It's just, it also gives kind of like the negative feedback to the player, telling them, hey, you screwed up. So if this worked the way that I think that it should, then what we will see in the scene view here is whenever we collide with something, we will see a line get drawn away from us, and it is not for some reason. Did I do something wrong? Might have done something wrong. Unless the ray is too tiny to be seen? So we're drawing at transformed out position and at the direction. Interesting. Let's do this, but let's normalize this. Right, okay, that's why. It's because the position difference is so tiny that it doesn't show anything, I think. I think that's the reason. So we'll say .normalize, and then we'll say the direction. I don't know if arrays have a fixed length. No array it can't have a fixed length, that's right. So yeah, now we should see something. Draw array has a duration parameter. I think it defaults to 0. Oh, is that right? Is that true? You might be right. I think you're right. I think it does default to 0. Oh, it has color and then a duration. All right, so let's try color.white, and then let's say duration for 1.0. You know, it might also be that it's, you might be right. It might be that it's not showing because of that. I forgot about that. Okay, let's try to hit something. No, it's not showing. Is my math just wrong? I'm trying to think. My math might just be wrong. That would be weird to me. Let's say debug.log. We'll say direction. I think vectors log correctly, if I remember right. So it should have an x and a y component. Okay, so it does have an x and a y component, but I don't know where it's drawing it, because it should be drawing it at transform.position, but it's just not. I mean, it looks correct, roughly speaking. So let's draw a line. Oh, I bet I know what it is. I think I know what happened. I think I might have clicked something in here. Or no, is it? There's a thing in here. Did I? Okay. I don't remember. Don't gizmos have to be on or something? I think that's what it is. Maybe I need a bigger. There we go. Okay. So what it was, need a bigger array, I think, as well. Yeah, okay. So what it was is I had accidentally toggled this gizmos button off. So as you can see in the because Unity has an amazing UI, you can see obviously this button is turned off right now. That's obviously what state that button is in. And obviously turning off gizmos, obviously turns off all arrays because that makes sense. I mean, of course, the debugger knows that you're trying to draw a ray. It knows the gizmos is off, so it's not drawing it, but of course it doesn't warn you about it. Obviously that button is in the on state right now. Everyone can tell that. God. Oh, it makes me so mad. Okay, I understand now. But yeah, I think you're right. I think the duration part was an issue. I also think that we needed a larger ray. But I had, like, the first thing I did was normalize it, so I think that was the main issue. I think right now it should work. But yeah, if you can't see rays in Unity, make sure you have the gizmos turned on, because apparently Unity doesn't help you with that. Yeah, you can see the ray flash into existence for a second. That was interesting. Yeah, you can see it sort of flash into existence for a second. Yeah, that's kind of what we want. Is we want that ray facing away from ourselves. And so what that tells us is that we can do a couple things. One, we can add force. We can say rigid body dot add force. So we can say add the direction, and let's say times 50, because forces need to actually be quite large to have any effect. And so the other problem is that I think since we're setting the velocity directly, I think it will basically just counter out the entire thing, or cancel it out. Maybe I'm wrong though. Yeah, the force isn't doing anything. Okay. So in that case, what we need to do is we need to have a bool to, what we want to do is we want to lock the player's controls for a second. That way the force can take effect. So we can say controls locked, or input locked, I guess, or we'll say movement locked. And then we'll have a protected float lock movement end. And so in handle movement, what we want to do is we want to say if movement locked, then we want to return. And before that, we want to say if time.time greater than movement lock end. We'll say if movement locked and that, then movement locked is equal to false. And then if movement locked is equal to that, so what we'll do is we will say in here, we will lock the movement, and then we will say that the end time for it is equal to time.time plus, and we'll say, I don't know, a quarter of a second. So for a quarter of a second, we'll be thrown back, and then we will regain control, which is kind of what we want. At least I think it is. So let's check it out. Okay, we're not being thrown back, and I'm not sure why. Maybe the collision is not, or maybe the force is not high enough. So let's change this to 500, that might be enough. Forces are kind of weird with how they work. I've never fully understood them in Unity. Like, I don't think they ever really explained the math. Okay, so that had some actual impact to it. So it's somewhere between 50 and 500. Probably, let's say 200. So let's check it out. But I mean, like, you would expect it to be sort of basic physics, and I think that's fine there. It's just having it kind of kick us back a little bit. That way we can sort of guarantee there's only one collision. And if we get other issues with it, we can make the player invulnerable for a second. But yeah, I don't know. So yeah, the whole physics thing, like, let me explain how Unity physics should, or how you would envision that it works and how it doesn't actually work. So what I would guess, if I were the one designing a physics engine, what I would imagine is that you would say, okay, a direction given a force that has a magnitude of 200 applied at a direction, that would be enough to move something of a mass of 1, like 200 units, right? However, that is not how it works, because we have mass 1, 0 drag, 0 angular drag. These also don't have colliders on them, so there's absolutely no friction whatsoever, and applying a thing of 200 only pushes us back a couple units. Unless it's like in tenths of a unit or something. That might be what it is that maybe this evaluates to like 2 units or something. Maybe? Is that approximately? No, because these are 1 unit across. It can't even be that. Because yeah, these are 2 units across. It couldn't be that, because that's only about 1 unit. So I don't know. I don't know what how the physics work. But they don't seem to they don't seem to work according to any like easily discernible math. Well, actually, wait a minute. If that's 2 units, no, wait, actually that might be how it works. Because we're pausing for a quarter of a second, so actually it would only push us approximately a quarter of a... Actually, you might be right. Maybe add force mode impulse. Actually, no, I think I might have just figured it out, because it pushed us about half a unit, and if it pushed us about half a unit, that would be... Okay. So if I understand what I just said, if what I said is just correct, then it should be the case. If this is 2 units, right? If it's in increments of 100, this should push us 2 units because we're locking the controls. This would be 200 units, or 2 units a second. Locking the controls for 1 second should cause us to be pushed 2 units. If all of that just made sense, I think that's actually how it works. I think I might have just discerned or divined how Unity physics work. Okay, I think that's exactly right. No, wait, maybe I'm wrong. Maybe I'm wrong. Actually, I think that's about right. Based on what I'm seeing here. Okay, maybe not. But I think, oh no, we got force applied multiple times there. But given that it was moving us about a quarter of a unit, or about half a unit, if we lock the controls for a quarter of a second, that would be approximately half a unit, or approximately a quarter of a unit, or no, half of a unit. Which I think is what we were getting, roughly. I mean, we could do some actual testing. Actual science. Okay, so if we align ourselves here, that was about a unit, so I don't know. So the force mode impulse. I thought force mode impulse was the default, or is it acceleration? Or is it, no, it must be force mode force. Continuous force, impulse, and instant force. Okay, let's try that. Because I always thought the default was impulse, but maybe I guess it's not. I guess it has to be the, well, I guess it could be, but we'll have to double check. Maybe that's a little, little too intense. Little bit much. I think though, if we do this, it's probably fine. That's funny. Okay. Yes, now you can lower it with the numbers. Makes sense. I think it's working. It's not working according to any logic that I know. But 2 is a little bit low. Maybe 20? Maybe it just lowers it by like a factor of something. Or like a factor of 10. I guess 20 units at a quarter of a second, or a quarter of a second would be 5 units roughly. If that's right. That might be 5. Playing bumper cars. I guess 2's a bit low, maybe 5? Okay, but yeah, I think... Okay, so it's good to know that the default force mode is not what I thought it was. I thought the default was impulse, but I guess it's not. Okay, so yeah, we get pushed back a little bit. That's kind of what I want. So yeah, okay. Thank you for pointing that out. Yeah, thank you for pointing that out. I like the number 5 a lot better than 500. But yeah, let's see what add force. Let's go to add force. See what their default is. The default. The thing that I'm not sure of is why the default needs to be force mode. I don't know why they need to put this default, because my thought was that an enum, if you didn't specify, defaulted to 0, to its 0 value. Maybe they do that just in case they rework the enum, but that is hard for me to comprehend. Or no, maybe the enum would just evaluate to null. Well, yeah, I don't know why they didn't do that, or why they did it that way. That's weird to me. Maybe it has to do with the Unity inspector. I don't know. That's weird. But yeah, I would have thought that it. Okay, so it defaults to force on everything. Yeah, defaults to force on everything. Okay, that's good to know. Yeah, so if you're having trouble with, I guess, if you're having trouble with force, or with add force, always try to change the force mode to impulse and see what you get. But I'm going to call it here for today, because my brain is a little bit melted, and it's about 10 minutes to noon. So I'm trying to think. I will probably, well, no, I'll definitely stream a little bit later. I'm trying to think of when, though. Yeah, I'll just stream at the normal time at 3 o'clock, but we'll do some more game development as opposed to the normal gaming stuff. What I'll do is I'll do some work on the game for the Dungeon Crawler Jam. Dungeon Crawler Jam 2021. That starts in 6 days. There is some stuff we can do ahead of time that I've been kind of messing with. So yeah, gonna work on that later today, probably in like 3 hours. Well, wait. Yeah, 3 o'clock. But yeah. Thank you guys for joining me. Thank you for all the help, guys, and I will see you in a bit. Or maybe tomorrow, depending on when you wanna watch.